Hey guys, as you know, we're starting our Calculus 2 stuff, which has to do with sequences and series. We've done a couple of days of it. We're just going to move forward in it, and we are on virtual learning. So the concept that is very important, something that we're going to build on for Calculus BC, we're learning on virtual learning. So it's really important that you are asking questions, that you are doing your homework, and that you are participating and watching these videos, okay? We're going to start off on this paper, your notebook, and then I'm going to use other paper so that it's a little bit bigger for you to be able to see it, okay? But the first thing that we're going to talk about is geometric power series and integration and differentiation of these power series, okay? So first of all, a series with variable terms like 1 plus x squared, we call that a power series. It basically has a variable in it, okay? So if I look at this power series, I've got the 1, and the next term is x, and then the next term is x squared. We're going to say this is a geometric power series. So in order for something to be a geometric power series, what is true? So we talked about how the absolute value of r has to be less than 1 if that's going to converge, okay? So I need to find what r is on this series. So how do I get from 1 to x, or from x to x squared, or from x squared to x cubed? From 1 to x, I multiply by x, right? So let's just go like this and say x is in between there. If I multiply by x again, I get x squared, and x again, I get x cubed. So is it fair to say that r is equal to x? Okay. If the absolute value of r is less than 1, then that means that negative 1 is less than r, which is less than 1. Okay. In a geometric power series, our r value has to be between negative 1 and positive 1. You can also write it like this, negative 1 to 1, but it has to be parentheses because it does not include the ones. So remember when we did this, it has to be less than 1, or if it diverges, it's greater than or equal to 1. Okay, so we're going to do the negative 1 to 1, or we're going to write it like this. Now, since this r is equal to x, then I'm going to say this interval of convergence, that's how we're going to abbreviate it, is IOC, is negative 1 is less than x, which is less than 1. Okay, so that's going to be our interval of convergence. So here, for these x values, we're going to add these all up together, and the equation is x to the n. Right? If n was 0, then I would get a 1. If n was 1, I would get a x. So it's like n equals 0, n equals 1, n equals 2, and that's how we're coming up with each of our terms. So our common ratio was x, and then we need to know what our first term is 1. So what would the sum be for this series? So something that you'll need to remember is a geometric sum is a over 1 minus r. Okay, that's going to be a really important formula for power series that we do today. So a in this series is 1, and then I do 1 minus r, and r is x. So I can rewrite this power series written out in the terms as 1 over 1 minus x, and it will have an interval of convergence of negative 1 to 1. Okay, so remember when we add things together, we use sigma notation. Okay, so sigma notation, this is going to start at 0. My equation is x to the n, and I'm going to infinity. So we're going to do this for some different examples to come up with these different power series of these functions, okay? All right, so again, this is really important, okay? One of these power series problems is usually one of the questions of the 6 free response questions on the AP test. Okay, so if you can get this down really well, that could be a +9 points added to your multiple choice score. Okay, so I have this equation and it says find a power series, show 4 terms and the general term, and given the series in sigma notation and the interval of convergence. So we have a few things to do here. I'm going to see if I can get this to focus a little bit better. But I don't know if it'll be. Okay. All right. So the first thing that I need to do when it asks me to do this is I want to find out what R is so that I can start writing out my terms. Okay. So if it was a geometric series, then A would equal 1 because this is in the form A over 1 minus R. Okay, so A is 1 and then 1 plus X. How do I convert that into a minus R? It would be 1 minus and then negative X, right? So R would be negative X in this case. Okay, so once we know what A is and what R is, I can write out my terms. So f of X equals, my first term is going to just be 1. Okay, then I'm going to multiply 1 times negative X and I get negative X. Multiply that by negative X again and we get negative X squared. Multiply that by negative X again and we get negative X cubed. Okay, and this is going to keep going until we get to our general term. Okay, so the general term, you have to have a plus in front of it because it keeps going, is just going to be the 1 times negative X to the n. And then it will keep going. Okay, so this is how we're going to write f of X. Now, this is going to equal the sum to infinity if n starts at 0 of the equation 1 times negative X to the n. All right, so oftentimes when we do these problems, if you have an alternating term, for the signs, okay, if the signs are alternating, then instead of putting a negative in with the X, we pull it in front of the negative 1, and we go negative 1 to the n, X to the n. So that's how you're going to see it the most often. This is the same thing, but this is more what you're going to see. Okay, so if I write this out, I'm going to end up with the sum of negative 1 to the n and then X to the n. Okay, so either one of these is correct. It did ask for the general term, so that's why I put the general term right here. This is our general term. Okay. But because we're writing sigma notation, we are also writing the general term. So you could write it like this one and save a little bit of writing, but this is preferred. Okay. So then we find the interval of convergence. Well, I know that the absolute value of R has to be less than 1. R is negative X. Okay. So this means negative 1 is less than X, which is less than 1, is our interval of convergence. Okay, so let's make sure we answered the question. So did we find a power series for each of the following functions? So here's our power series. Okay, we wrote it out. We showed 4 terms. We showed the general term. We wrote sigma notation, and we wrote the interval of convergence. Okay, so we made sure and we showed all of the parts that it asked for. So sometimes when it asks for more than one thing, you want to go back through and make sure you got them all. Okay, let's do it again for g of x. Okay, so At this point, I want you to pause the video and try to do this. Write down what A is and write down what R is. So remember, it's in the form of A over 1 minus R. So A is 3 and R is 2x. Okay, so G of x will equal, I start with a 3, and then I multiply by 2x, and we get 6x. And then we multiply by 2x again, and we get 12x squared, and it wants 4 terms. So I'm going to write 1, 2, 3, 4. Okay, so I have 4 terms. And typically when it asks for 4 terms, it's 4 non-zero terms. Okay, plus, and then our general term is 3 times 2x to the n plus, okay, and that equals 3 times 2x to the n, and I need to see what I want n to start at. So I make sure if I start n at 0, if I plug a 0 in here, I get 2x to the 0 power is 1, and 1 times 3 is 3, and that is my first term. So you always want to double check that your notation matches if you plug in to get your first term. Okay, now our interval of convergence is R has to be less than 1. Okay, so -1 is less than 2x, which is less than 1, and we divide everything by 2. So -1/2 is less than x, which is less than +1/2 is our interval of convergence. Okay. All right, so the next one that we're going to do, we have to figure out R. It's not quite as easy to get there. Okay, so I know that it's 1 over A, I wrote that backwards, A over 1 minus R, okay? So I know that A is the 1, and then I know that 1 minus R is equal to 3x, because the bottom is 3x, and the bottom has to be 1 minus R to be a geometric series, okay? So, and it says to write it as a geometric series, so I'm going to make R work. So if I add the R over here and subtract the 3x, we get R equals 1 minus 3x. Okay, so if I write the power series out, the first term is a 1, and then I multiply 1 times 1 minus 3x. Okay, and then I multiply this by 1 minus 3x again. And you notice that this is just going to increase the power of that binomial. Okay, so 1, 2, 3, 4. So we've got 4 terms. Okay, and then the general term is going to be 1 minus 3x to the n. And for the first n, it's going to be 0, so that I get 1. Okay, now the interval of convergence. So I'm going to take my R is less than 1, and solve for x. If I solve for x here, I'm going to subtract the 1. Now I want you to notice that here I have a -3. When we divide by a -3, it switches these around. So it's going to be 2/3, and then it's going to go this way. Instead of writing this step, I always just rearrange my numbers so that they're in order. Okay, so our interval of convergence is going to be 0 to 2/3. Okay, so that's the first step, is to understand how we can get a function to turn into a power series, and we can write the power series. Okay, so now we're going to take that power series and we're going to replace x and write a new power series. Okay, so this says, using the power series from example 1, make a new power series for f of x squared. So in example 1, I'll just write that out again. 1 over 1 plus x equaled 1 minus x squared plus, oops, sorry, I did this sign wrong. 1 minus x plus x squared minus x cubed. The signs alternate. Okay? So what I'm going to do here is, instead of f of x, I'm doing f of x squared, which is the function 1 over 1 plus x squared. So my only difference is here is that everywhere I have an x, I'm going to put x squared instead. So 1 minus, and instead of x, and I'm going to do it in parentheses, I write x squared. Okay? And then instead of x here, I put x, and then that's squared. Instead of x here, we put x squared, and then that's cubed. So everywhere I had an x is my parentheses. So x went here for this one, x went here for this one, and x went here for this one. Okay, so x cubed, x squared. So if we simplify that, we get 1 minus x squared plus x to the 4th minus x to the 6th. Okay, so make sure that you always continue your plus and your dot, dot, dot. You will lose points if you don't do that. And then make sure that you replace the x with whatever it's asking you to replace it with, and then do the power or whatever that it's asking you to do, whatever the formula says to do with that replacement. Okay, so if you want to think about it, like, I'm going to write this, and instead of x, I'm going to have a box. Okay, like this. And then everywhere there's a box, I'm going to put x squared. So this box will be x squared, this box will be x squared, and this box will be x squared. And then that's how you can see it's x squared to the 3rd is x to the 6th. X squared squared is x to the 4th, and so on. Okay. All right, we do that one more time with g, and this is example 2. So let's write out example 2 real quick. So 3 plus 6x plus 12x squared. I better raise my arms so the lights don't turn off on me. Okay. And then plus 24x cubed. So this was our original g of x on example 2. And I'm going to do g of box. Okay. So 3 plus 6 times a box plus 12 times x box, 24 box cubed. Okay, but instead of a box, we're putting root x. Okay, so everywhere you have a box, you're going to write root x. Okay, hopefully that box is a good visual for you to see how to do that. We want to simplify, so we get 3 plus 6 times root x. And then square root of x squared is just 12x. Okay. From that point forward, we're just going to write it as a power. So this is a square root, and this is a 3. So 24x to the 3 halves. And then we would just keep going from there. Okay. And you could kind of see this is a 1/2 power. This is a 1 power. This is 3 halves. So the power is increasing by 1/2. Which is exactly what a square root is. Okay. All right, let's get to some fun stuff now. So now we're going to take the derivative of a power series. So if I have my power series of f of x is 1 over 1 minus x, okay, that is equal to 1 plus x plus x squared plus dot, dot, dot. Now this doesn't say general term or anything, so if I just do, and it doesn't even say how many terms, So we don't have to, we can just usually do 3 or 4, okay? So I'm going to take the derivative of this one term at a time. The derivative of 1 is 0. The derivative of x is 1. The derivative of x squared is 2x. The derivative of x cubed is 3x squared, okay? So we can come up with the derivative of a power series by taking the derivative one term at a time, okay? Take derivative one term at a time. Okay. What if we go backwards and we take the integral? We could do that, but I forgot we have one more example. So let's do this. So we're going to find the derivative of j of x. So one term at a time. The derivative of 1 is 0. The derivative of x is 1. The derivative of x squared over 2 factorial is 2x over 2 factorial. 3x squared over 3 factorial. 4x cubed over 4 factorial. Okay, so hopefully you're seeing this pattern that I'm going to be able to cross off one of these. So j prime of x equals 1, and then the 2 will cancel out, and I'm left with x. The 3 will cancel out, and I'm left with because 3 factorial is 3 times 2 times 1. So the 3 crosses off, and you're left with 2 factorial. So x squared over 2 factorial plus x cubed over 3 factorial. Okay, now I look at that. This was my function, and this is the derivative. So this is the function, and this is the derivative. So can you identify that function? What function is the actual function and the derivative of the function the same? Where is the function and the derivative of the function the same? E to the x. Okay, so you have just learned the power series for e to the x. And the reason why is because j of x is equal to j prime of x. Okay? All right. I know you guys are getting really excited now. We have 3 more examples, and it's actually all combined to this one. We're just going to do it a step at a time. So the first thing we're going to do is we're going to say that the power series 1 over 1 plus t equals 1 minus t plus t squared minus t cubed. Remember, this is your power series, right? We're going to take the integral of that by integrating both sides. Okay? So the integral of 1 over 1 plus t is the natural log of 1 plus t evaluated from 0 to x. And then the integral of these, I just do one term at a time. So the integral of 1 is t, and then the integral of t is t squared over 2, t cubed over 3. Okay, and this one is positive, negative, positive, and then negative. I could keep going, okay? So this is going to keep going, right? And it's evaluated from 0 to x. Okay, now what you need to remember is that the interval of convergence is between, it has to be negative 1 to 1. So I don't need to worry about absolute values because I'm not going to come up with a 0 or a negative number anywhere. So I can put it in parentheses. So, and I plug in an x, and I get 1 plus x minus the natural log of 1. Okay, and then we substitute in here, we get x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4, and then plus, and then minus 0. Okay, so we've taken the integral of both sides to get this. Okay, so 0 is just 0, so I can say the natural log of 1 plus x is equal to x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4. Okay, and they've come up with a power series for a natural log. Okay, so the power series for the natural log, and this is natural log of 1 plus x. So when we get down to the next example, we're going to, instead of have 1 plus x, I want to just know the natural log of x, because that's a function that we use quite often, is just the natural log of x. Okay, so we're going to use those results to write the natural log of x. So I have to make the natural log of x plus 1 plus x, into the natural log of x. So I need to get rid of a 1 right here. So I'm going to replace my x with an x minus 1. Okay, so if I do the natural log of x is equal to the natural log of 1 plus, and then if I change that r value or that x value into x minus 1, that's the same thing because the 1's cancel out. So all I need to do in my power series that I already know, okay, this is my power series that I already know. Make sure I wrote that right. Okay, I'm going to replace this with x minus 1. Instead of x, I'm doing x minus 1. So instead of this x, I'm going to write x minus 1. Okay, and then instead of this x, this is the same as our box, right? I'm going to write x minus 1. And then I'm going to write x minus 1 in this x. Hopefully you can start to see that pattern. Okay, so this is going to be another power series you'll have to memorize. You'll need to know e to the x. You'll need to know natural log of x, and then sine and cosine. Okay, so this is the natural log of x. And I can manipulate these power series by replacing something and making it the same thing, equal to, equivalent to the same thing, like we did right here. I took the x minus 1, and it still equaled the same thing. Okay, so now it's going to go one step further and say, write the series for g of x equals x squared natural log x. Well, I already know that the natural log of x, and let's not call it g yet, let's call it f of x. I know that the natural log of x is x minus 1 minus x minus 1 squared over 2 plus x minus 1 cubed over 3, okay? It doesn't tell me how many terms, so I'm just going to stop here. So now g of x is one step further. It's x squared times the natural log of x. So I'm going to take my natural log of x that I already know, and I'm going to multiply every term by x squared. So x squared times x minus 1 minus x squared times x minus 1 squared all over 2 plus x squared times x minus 1 cubed all over 3. And we would just follow that same pattern. Okay, so this is just giving you the tip of the iceberg introduction to these power series and how we use them to write functions that we already know. Okay, I have a canker on the tip of my tongue, so if you notice that I am lisping a little bit, that's why, because it hurts so bad when I say certain letters like S. It really hurts. Anyway, all right, so you guys are good. We're going to talk about this. We're going to go over it and over it and over it until you get it, okay? Let me know if you have any questions. See ya.